afraid that you might be in the wrong room. Otherwise, like before we start, it would be good for us always to have introductions so that we have an idea of who's joining these activities. My name is Sidney Nakaholo. I'm one of the founders of NewSpace NYC and also faculty here at Columbia. I think we go around.
Yeah, my name is Vivek, and I've been dabbling in the aerospace projects.
Oh, good.
And prior to that, I've been exclusively on Wall Street, and once upon a time I was doing my PhD in physics, dabbling in cosmology.
Yeah, right. Yeah.
What are you doing right now?
Well, classified. To be elaborated upon.
Good. Okay. By the way, there's live streaming, so if there's information that you would like not to be disclosed, just feel good. Just pay attention to this.
Yeah.
Hi, I'm Sonia. I'm passionate about space. I'm currently implementing data analysis for the city.
Michael Benjamin, I have a systems engineering background in space.
My name is David Bullock, and I am the senior editor at NewSpace Global.
Oh, great.
My name is Ruben Safer. I'm a graduate student at Cornell University in computer science and mathematics, and a long-time Linux programmer. So that's it.
I'm Steve Wolf. I'm the program director for SpaceCom, which is a new commercial space conference and exposition that's coming to Houston in the fall in cooperation with NASA and JSC and the Houston business community. So we're very interested in what's going on in commercial space in every corner. So especially here, and I'm from New York, so very excited to be connected with this group.
Glad you're here. Kathy Radway, co-founder of NewSpace. Been around the NewSpace industry for over 10 years now.
Mike, you should.
Oh, I always forget. Hey, I'm Mike. I am part of NewSpace. So we started in October. Before that, I was Tong Sean. I was part of Solar System Express for about a couple years. So we have a little like Arduino, but it's like space rated. So high radiation, high low temperatures, that kind of stuff. And then my day job is web engineer.
Or let them. Or let them.
Yeah, but it's handy because I get to help out a lot of people need better websites. Yeah.
Well, I would say that part of that is being in the Bay Area and being out in Ames, hanging out with a lot of other software and hacker people. Many times I run into Google employees and they would say, I used to be an aerospace engineer, but I'm now blah, feeling.
It's not the same thing.
Well,
There's
it's
two things that's different.
okay.
Well, you were talking about New York, so but I don't want to give you a whole background of New York. New York is not the West Coast. It's not California. I'm in California. You can sit down at a beer outside of Stanford, outside of HP, after a meeting, and sit there and work with 4 job workers and two, and so everybody's trying to show you this. This is not the way New York City is. New York City, it's hard to get space to meet. It's like the fact that we have floors and floors and floors of empty space. New York is just not San Francisco. The other thing is that our IT people here are not doing a lot of research development, at least not the way we do it. Our IT people here are doing finance and retail. This is a city of commerce. We don't do a whole lot of that hardcore kernel programming here. And I know that I've had to make choices between moving. We're moving to the West Coast, to do what I want to do. I want to stay in New York for a number of reasons. But it's not the same. You're not saying with Google that is in New York, it's not the Google.
Yeah. Well, coming from an astrophysics background, I certainly know a lot of cosmologists who ended up in finance, for obvious reasons. And, it's kind of a rational choice. And likewise, for the aerospace engineers that are in the Bay Area, they ended up at Google, and that's for an obvious choice because, the opportunities in the traditional aerospace industry are, not necessarily that attractive. people that are working for major aerospace companies who, have ended up, I mean, I spent 15 years working on the Sophia program, and we had a bunch of people from Lockheed or Ball or whatever, mid-career people that are like, this is not good. I'm not happy with what I'm doing. And I've even seen people that aren't able to get the research funded and they leave and they go off. And so what to me is exciting about the new space industry is that you see a lot of vitality. You see aerospace engineers that are excited about working in the industry. And there was a time when people were asking me, you get emails from people and they'll say, oh, I'm a young student, where should I do? And, should I apply here or should I apply there? And it was about the time that they were working on the original X Prize. And as I was kind of going through my options of, okay, you could work for NASA. I'm like, all right, well, you could work for one of these commercial companies. I'm like, Actually, I think my best answer was, why don't you go take a look at the guys that are competing for the X Prize and see if you could go work for those companies. Because to me, that was an exciting opportunity where you've got engineers that are not sitting there on a computer doing design, shuffling paper, but they're actually building hardware. And you'll see a lot of those companies, because of the X Prize. And the other things that were happening down in Mojave, you see a lot of those companies down in Mojave. Certainly X-Corp is one of those examples. It has a lot of engineers that are busy making hardware and flying it. So I kind of feel that the new space industry has breathed new life into aerospace, and people are excited. I mean, young engineers that are graduating from school are like, I want to go work at SpaceX. What can I do to go work at SpaceX? And SpaceX is a freaking pressure cooker. In my, knowing some of the guys that work there, and it's amazing to see what Musk does. But it comes. I know guys that are down there and they're like, I'm taking a year off. I'm going down the Antarctic to go do something else for a while. And one of the guys I know who's building telescopes for the moon and other places, but he literally, and so it's a tough, high pressure environment for people, but I think it's breathing. It makes it exciting for the aerospace industry. And so in that sense, I think new space is really important. So I've got a few slides, and this is a combination of things that I've presented in the past, but I thought I would talk a little bit about what I'm doing in the Bay Area with Silicon Valley Space Center. I'm really happy to be here in New York because we were talking before we got started, one of my big questions was, well, I know what California is doing, I know what Texas is doing, and I know what Florida is doing for new space. The fourth most populous state in the union, New York. What's New York doing for new space? And that goes all the way from what's the state doing to what are companies doing to what are individuals doing, and what's happening in the educational front. And so when I was planning my trip out to the East Coast, I reached out to Khaki and said, hey, I think there's this new space group here in New York. Can you get me plugged into what's happening? So I really wanted to come out here. And I also grew up on Long Island, take the Long Island Railroad out to Manhasset. That's where I'm from. So, and I'm a graduate of Columbia and Berkeley MBA programs, and actually came out here in the fall of 2008 to spend more time in New York and spent my time kind of commuting back and forth, which is, I would not recommend that to anybody. Every other weekend right between San Francisco and Kennedy, but it was also a good time to be here because that's when the entire market collapsed, and Lehman Brothers went belly up, and 2 weeks later they were Barclays Capital or something. So yeah, so it was a good time to be out in New York, during one of the major financial crises of our time. But aside from that, basically glad to be here. So a little bit about Silicon Valley Space Center. We've had some write-up from NewSpace Global. I know Richard David pretty well. And Silicon Valley Space Center, it was in part listening to the aerospace engineers that were now working for Google saying, there's some impedance matching that needs to happen between aerospace engineers and the startup community. And so having worked with a couple of groups in the past to help them get them started, I created the Silicon Valley Space Center, which is intended as an incubator for aerospace startups. And we got started in about 2011 and 2012. I went full time on Silicon Valley Space Center, and done a couple of other things while I was part of this. While I was part of the center, but we're really focused on, say, building a karatsu of companies that can work with one another in supporting their business models and for the new space industry. These are some of the companies that we are working with and that we work with. There's Positron Dynamics, which is actually a spin out from one of the early GLXP teams. And Vital Space is doing biomedical sensors. I really don't want to talk about those in great detail, but we have a number of companies that we support. Some of them, like Manu Sharma for Infinity Aerospace. I think Manu is finished at Stanford, has gone on to do some other things, but it's still kind of kicking around on a low boil. But we tried to develop companies that are geared towards the new space sector, along with some working relationships. I like to think I have a good working relationship with XCOR, Planetary Sciences Institute, CASIS, SETI, and an organization called the Hacker Dojo, which is in the Bay Area. Aside from working with entrepreneurs in an incubator fashion, we also support a variety of Bay Area events. In 2011, we did the first Space is Not for Billionaires Anymore event with the MIT Stanford Venture Lab. A lot of those presentations, if you just go to VLab, they're online and you can download them. We did 2011 with a variety of companies that were featured. NanoRacks. Rich Purnell was actually at NanoRacks at the time. Bob Richards from Moon Express, Will Pomerantz from Virgin Galactic, and Al Todros from Space Systems Go-Round. And the purpose of that in 2011 was to say, look, there are opportunities to fly that are kind of consistent with angel level of funding. For several $1 million, you can develop your payload and fly it. At the time, NanoRacks was really focused on the CubeSat launch market. They were really looking at things that were internal to the ISS. But we did that event. We also did an event with XCOR, which was focused on small payloads. But as the event evolved, it really focused more on the citizen astronaut perspective. The fact that you could get a ticket and fly, and then fly with a bunch of payloads that were microgravity payloads that could come from researchers or educational institutions. We did an event on biomedical devices. We actually had the chief medical officer for the Red Bull jump, and that was actually kind of interesting. But really, a number of people talking about the physiological effects and the kind of new technology that was flowing into that space for spaceflight participants, and then later on we did an event with CASIS, focused on the microgravity aspects and things that are important for operations on the International Space Station. Those events we do every so often, probably one a year, on a boutique topic. And usually those events are usually geared towards the companies that we're supporting, so as a way of promoting the technology. We also, in the Bay Area, do a monthly talk series where I try and bring in, from my own background in science and engineering, try and pick out those companies that I think are interesting. And through this, we've actually picked out some fairly early companies. We had one of the first companies I wanted to present in 2011 was the PhoneSat crowd, and it was Boschhausen and the Cosmogia guys. And it wasn't really clear to me what exactly they were doing at that time, but they were pretty much incubating their early idea for what was Cosmogia, and then what would later turn into Planet Labs. We've also featured GLXP teams. Jason Dunn from Maiden Space talked about their flights on the zero-G vehicle. We talked about lunar mining, and certainly a lot of talks about CubeSats as small payloads. And I think that's one of those things where it's sort of more of a passion of mine to bring out the engineering companies and really talk about the technology and in some sense, how does that make an attractive company if possible, or just what people are working on. So we've got student groups that are presenting engine designs, companies that are doing CubeSats, companies that are doing ground stations, and most of those they're not online because I don't have my act together like some people here, and being able to record stuff. But anyway, we're working on making that happen, and we also support some student groups every so often. This is a student group we had from Puerto Rico, which I thought they did an outstanding job. They came out to NASA and were there for 7 weeks and learned how to use 3D printers and laser cutters. And they built a suite of greenhouse modules. Those were all 2U modules that were run by Arduinos, and then all the data was collected by Raspberry Pis. And the intent was to build a system that you could deploy on the International Space Station later on. You can't really deploy this to the ISS, but certainly getting all the systems engineering, getting all that worked out, getting all the software worked out, and kind of making that available. So we try, I don't necessarily make it a habit of working with students, but I think it's important to encourage students. And again, this was leveraging some of the Arduino technology that were part of the companies that were incubating at the time. So that's kind of in a nutshell the things that I cover on the Silicon Valley Space Center. But one of the things I like to emphasize, and this was a story, I was over, my car had broken down, and it was over to Hertz, dropped my car off over to Hertz to rent a car, because I got to get over to Moffett or wherever the heck the dojo. And I go over to Hertz, and there's this thing 24/7. And I'm like, oh, what's that? I don't know anything about that. I'm a gold card member. But 24/7 is a way where you can just get cars on short notice. You just show up, you unlock the car, and go. When I was asking the guy, like, where did that come from? He's like, oh, Zipcar? It's like Zipcar. And it made me think, well, here, if you remember the Zipcar story, when these guys were getting going, a lot of people are like, why are you doing that? How are you going to compete against Hertz and Avis and Enterprise, a lot of other players in that space? And Zipcar, there were probably a number of other, and there still are, on-demand car rental services. And Zipcar, in the end, and this is what this shows, Chrysler, the chairman of Chrysler, and the chairman of Ford, after they acquired Zipcar for Avis, or when Avis acquired Zipcar. And it was, like all stories, it says, it's sort of a tale of woe in the startup environment. But to me, it shows that, it's not big companies that innovate. It's entrepreneurs that innovate. And the role of big companies can be to acquire the technology that entrepreneurs provide. And that in the aerospace sector, I would say it's kind of the same thing, that it's the role of entrepreneurs to provide innovation. And then for investors, the good news is that you can have an exit. And that exit can come from the larger companies. And so it's not, you don't have to think, well, big companies are not innovating, shame on them. I don't think big companies are required to innovate. It's the small entrepreneurs that are required to innovate. To me, this is an example of what happens in the new space sector. You've got entrepreneurs that have an idea. There are a lot of entrepreneurs kind of working on various different models. They experiment, they try, and the best of those are the ones that end up being acquired and end up being a success story, like Zipcar. So the purpose of this is that it's not big companies that have to innovate, it's the small companies. And so only when you have a healthy ecosystem is that really the case.
What do you think about this Airbus investing $150 million
In their innovation center.
Innovation center? They're basically being proactive.
Yeah.
In sort of searching for those innovations.
I would say I know.
There's a reaction out there. To their coming.
Right. And having discussed that with those guys, I don't know, somehow we made a connection, and we brought them when they had some of their Airbus executives. We brought them out to River, which is a virtual reality incubator run by Rothenberg Ventures. And we're looking at, how could you use some of the technology associated with virtual reality and Oculus Rift and those things? How could that apply to what Airbus wanted to do? And if you drive down 101, you'll see that BMW is there, Toyota is there, Hyundai is there, and I think those are companies that are looking for innovation. And the challenge for big companies is, how do we create an environment that's safe for people to innovate? So am I surprised that Airbus is there? No, not really. Whether they find what they're looking for, that's TBD. But I think that's the challenge for big companies, is to say, how can we get new technology and migrate it into our company to do things that were otherwise not doing to make us competitive. So
I read about this today in the newspaper that Airbus will be investing a very significant chunk in Bangalore, India, to replicate the delivery model. So I think there are 3 or 4 centers that will be seated. But India is getting a lot of attention. I mean, the VC activity is just skyrocketing.
Is it becoming an alternative to in-house R&D departments rather than trying to get it cheaper and more
Perhaps.
cost-effective?
Yeah, perhaps. And is that the flavor of the day? to be determined. I don't know if the Airbus guys were particularly happy at the introduction I provided to the dealer, whether they got to see, but you're walking around in the Bay Area and you can pick and choose, right? It's a mixed bag, and but it is where innovation is happening, and I think entrepreneurs have the permission to innovate. If you're working in a large company, I don't know if you have that permission. And even at Google, 25% of their time is geared towards doing whatever you want to do, and there's kind of a competition among these. So maybe big companies can adopt that, but it's certainly a challenge for large companies. And is it, are you incentivized to do that? Clearly, in the entrepreneurial case, you are incentivized to go make that thing work. You quit your job, your entire focus is on that effort. Whoever's at home is probably saying, "What are you doing?" Right?
Or they're not home for very long.
Yeah.
Very long.
Right. So anyway, but with that, I would say that if you just look, this is a snapshot of what we've seen over the last couple of years, and not that. And just in the spring, I was out at the Satellite 2015 conference in Washington D.C., which is sort of a lot of the old guard of satellite communications industry, satellites, ground stations, and Satellite Executive of the Year is Dan Birkenstock. So a lot of the buzz for Satellite 2015 in Washington, D.C. was about Virgin Galactic, their Launcher One, what's going on with OneWeb, Dan Birkenstock, the acquisition of Skybox by Google. And, I was part of a panel with Wake Davidson and Richard David, and also Peter Plotzer on West Coast meets East Coast. What does that story look like? And I think that Silicon Valley in the Bay Area, or the NewSpace, I'll just say NewSpace. I mean, these are all Bay Area companies, but what you're seeing is Skybox getting its start in 2009, Planet Labs, and all of them. That's $100 million raised in 4 rounds, and I believe that they're above that right now. even Spire, looking at weather measurements and maritime communications, and most recently Satellogia, which got $2 million from Tencent. And so all of this is within the last 5 years, and there's other companies that are here. This is just on the hardware end. There's also SpaceNo, people that are working on the analytics. And if you look at what these companies are, they kind of fall into really three areas that you see is sensors, big data, and analytics. And that's kind of a common theme for biomedical devices, for big data. You've got some sensor that's actually collecting the data, it's aggregating into a big database that you're able to manage. And then how do you do the analytics on that and turn it into a revenue generating?
So,
Sure.
not to nitpick, but I find this statistic very interesting. This maritime domain awareness and whether this $12 billion. Because I've heard very wide range of numbers from all the way to global market is only $200 million, strictly speaking, or anything maritime is legit. So it's comes into tens of billions of dollars. So I'm just saying I find it interesting.
Yeah, I think there's questions about how big that market size is.
Right.
But what I would say is a lot of these guys are working in a market where climate change is a major issue, right? A major issue for the planet, and anybody that has ever a global perspective on that can be a very attractive business.
Yeah.
I mean, how these guys clearly, there's actually sensors, big data, analytics, and a market and customers. And all these guys, if you look at the Iridium story, where did Iridium run into trouble? Excellent technical execution, very poor execution on the market. So,
What's Iridium? Besides a footprint for dinosaurs, what's Iridium?
the Iridium satellite constellation.
Iridium.
Yeah, right.
The one thing, mobile system is very large.
The handset, though.
It was, the mobile market, but I think it was also, it was kind of poorly timed with the rise of mobile cell phone. But I also think that the company itself wasn't really focused on how the market, how to reach out to the market and how to, in the end, it was sold for $25 million and repurposed to a different market segment, in particular looking at the government market. But, for all of these companies, clearly the issue is, can I get a handle on the market? And yeah, even though I'm doing the analytics and I'm, generating data product, how do I reach that? How do I reach out to the market and monetize that? And that's not a science or engineering problem. That's really a marketing problem, and really understanding the market.
So what's the upshot? What's the difference between these two lines?
Well, I don't know. I'm not out. What's the difference? I'm out here to find out.
No, I mean, you were at the SAT conference, the
yeah.
small SAT conference in March.
Yeah,
I think.
right.
You guys were on a panel and you were discussing that. And so was there an upshot at the end of your discussion, or did you leave us hanging?
Yeah, no, I'll get to that.
You get to-
I'll get to that. Yeah. So I'll get to that. That's kind of like, I think, the next slide here on that. And
Just
that.
one quick question.
Yeah, sure.
The idea that you're doing analytics on the data set,
Mhm.
that's what the guys who are doing
Mhm.
they're launching satellites
Mhm.
to support that. How does that play with some of the things that NASA is doing with its data that they're just kind of explaining for free? They've got satellites up there that are detecting stuff, they've got millions of data. And
Yeah, sure. Well, yeah, probably if you look at the GOI data, I think people were talking about just how does NASA make that data available? Is it readily available? Are you, you could say, gee, NASA needs to be selling that data. NASA needs to be analyzing that data and make it available. And
I'm sorry, you said GOI.
the GOI satellite, the imaging satellite that provided a lot of Earth-based based data. I would say it's kind of up to you if you create a ecosystem where a variety of people are allowed to analyze the data and make it available in a commercial sense. That's kind of a better solution than the government coming in and doing whatever it's going to do, and it has done that. There's an article from by Pete Warden on commercial space when he was part of SDI. This was in '94. And he's talking about here's the Landsat data and how it's going to be available and what happened to the commercial potential of the Landsat data. And I think there were a lot of political issues associated with the government and who's doing what and how the data is going to be processed and who's paying for it. And the Landsat data really didn't turn out to provide the economic benefits that it should have, and that some of the people that were working on Landsat thought that it should have. Whereas if you look at Planet Labs has taken that same model that Pete Warden was talking about in '94, and Skybox has done the same thing. And instead of saying, gee, the government is part of my supply chain, they've kind of swapped that out and they put their own component in there as part of this supply chain. Planet Labs, it's not a satellite company, it's a software and data company. Skybox is a software and data company. They have satellites much like Google has servers. They're not in the server business, but they require servers to do their job. And I think the success of Google relied upon their ability to develop the servers that they needed for their search engine. Likewise, Skybox and Planet Labs can develop the hardware that they need for their analysis later on. And so the model is the same as what Pete Warden was talking about in '94, but you fast forward to 2010 and 2012, and you have technology that allowed those companies to put that hardware in place as part of their own supply chain, and then turn the crank and get the big data, do the analytics later on. So, I mean, yeah, the government could do it. They've had
Well,
enough.
they are. I mean, there's data about that,
Yeah.
They're exposing it in there. We need to do more of that.
Yeah.
But I think one of the interesting things that you're pointing out is the difference between a private concern that is using a hardware platform that is tailored towards the kind of data that they're getting. Not really going after a particular mission that they are seeing an extension of commercial value coming from, as opposed to NASA doing some research and having huge sets of data that are, kind of like your grandma's attic. You'll find some treasures in there, but it's not really.
Yeah, and my own take on the government end on things is, where does government show up? Government shows up where companies cannot evaluate the risk for doing whatever it is. Right? I mean, if I'm going to do JWST, right, there's a lot of risk associated with doing the mission. Hard to price that out. Investors, what am I going to ask for as a return on investment? What's the risk of that thing failing? So government steps in where you really can't price out the risk, and you need to get the job done, and the government will do it at all costs. And I also think that nobody buys T-bills because of the risk involved, and that the government is inherently unhappy with anything that's got kind of risk in it. So the notion that Dan Golden's cheaper, faster, better, where you're going to have some failures and everything would be okay. It's generally not okay, because people get all upset and they're like, why is the government failing on this? And I think that's because you don't expect the government to fail. You don't expect the T-bills to fail. You don't expect your satellites to fail. And so that drives the cost up to where it is, because failure is not an option on that. Whereas for Planet Labs, they've built a system where they can tolerate some failure. They can tolerate losing 20 of their satellites and moving forward. So that's just my 2 cents on that. And,
But if you were to, analyze revenue versus sensors versus data versus analytics, how would you rank this? As I'm understanding, it's a cognitive engine. The big data analytics just customizing the solution for the end customer, which is the most crucial part. And I could be mistaken, but in the optical realm, the world is awash with low resolution optical information worldwide. So therefore, what is the rigorous logic behind launching your own hardware in this day and age? I can understand conceptually that you want to dominate the game. It's a feel-good factor.
Yeah,
But
well,
is there a deep logic behind hardware?
I think I would treat that as a choice between build versus buy. And if you look at Skybox started, I believe, with the small satellite, CubeSat type market. You talk to the founders are like, oh, we're going to do a bunch of CubeSats. And in the end, they settled on a larger system that has a smaller footprint on the ground, and that's kind of what they're building. And how are they building their satellites? They're not building them internally. They provide some internal part of it, but they're building them at space systems low out. Planet Labs, on the other hand, decided that they really wanted to maintain control of the hardware and are probably riding the small sat wave and looking at the technology innovation that's coming out of that. Whether the Planet Labs satellites evolve in aperture to a larger diffraction limit, might be TBD. And you might look at, I can only speculate, but you might look at the problems that Skybox is doing versus what Planet Labs is doing. That Skybox could say, oh, look, we're going to put this satellite up. We want to generate our revenue from that. Whereas Planet Labs could say, we are actually looking at the problem of flying constellations of satellites. And so that's the problem that we want to work on. We want to understand, how do we launch satellites? How do they all work together? How do things drop out of the constellation? How do you add other things into the constellation? How can I add different imaging capabilities that can sort of come online? How can I build that? And I think
huge problem. How many privately owned satellites
well, I know that Planet Labs, from what I've heard of these guys, they rank number 7 or number 8 in terms of entities that own assets in orbit. So I believe I would venture to say that. Yeah.
Well, don't they launch a dozen at a time?
Yeah. And they launched, I think they launched 20 in the orbital. But missed that.
Right.
So
how many of you are we setting up that privately owned?
I don't know. We'd have to ask NanoRacks and maybe NewSpace Global.
Well,
No.
yeah, it depends. You want to go to Comline, you want to go to private is also satellite TV, communications.
Well, no,
Not
it
even-
doesn't go on a NASA rocket, on a military rocket, when you set it up private, right?
No.
Well, there's no NASA rocket. They're all commercial rockets.
Right.
They're all commercial companies that are providing the ride. NASA's footing the bill, as opposed to Hughes footing the bill or DirecTV footing the
So who's regulating that? Because you can't just keep shooting stuff into space.
No, that's the problem.
And the stuff is gonna come down also.
Yeah. So, no, there's also collisions
Oh.
and, the orbital debris problem. So, and, I think the thinking is for the low Earth orbit and Planet Labs that, these things are burning up in the Earth's atmosphere. So they're not raining down. When you have satellites that have reactors on them.
Plutonium reactor.
That's serious. That's serious business. And when Skylab came down, there was a big lead safe that stored all the UV sensitive film that was used as part of the program. So, and there's probably issues associated with that, but there's also probably issues associated with being able to monitor all that material. And, it's for stuff that's at higher orbits where the lifetime is not 6 months or a year, but several years, if not longer, where you run into tracking problems.
Do you need additional one?
You have to file a license for launches. So, and you have to say, what am I going to do? Right? So you have to, and there are a variety of, you have to have permission for the launch, you have to have permission for communications, you have to have permission for where you're going to be looking.
So this is definitely not do it yourself yet, despite the fact that you have silicon eating do it yourself space.
it's, you know, it's,
Well, but I
yeah.
mean, I don't mean to put you on the spot, but,
oh, it's a non-trivial problem, but it is doable, right? And, you know, I think the FCC has gotten a big windfall of requests for radio spectrum, further communications, and more so that they know more requests than they really know how to deal with all that. So there's certainly issues with all the launch process, and you know, is the government really geared up for launching this stuff on a timely basis? But you know, you're having a bunch of companies coming online that are requesting radio spectrum, that are requesting licenses for observing, not only observing looking at the ground, but also looking elsewhere.
Yeah, and if you look at the Earth, don't you have to go through NOAA as well?
Yeah, right.
You have to get approved by NOAA.
Mm-hmm. Well, I think, you know, one of the issues, for instance, is launching with India, and that, you know, U.S. payloads can't really launch with the Indians. And I think, you know, under the State Department, they relaxed that, so now research payloads can launch on Indian vehicles. But,
that's good, just try to lose Pakistan.
well, you're just
That was really funny, you guys totally missed this.
so, but you know, that's, you know, there are barriers to entry. I mean, there are barriers to entry. I mean, people build barriers, so like we can't have Tesla cars in Texas. So, and the U.S. launch industry is sensitive to that. Yes, sir.
Is anyone working on a standard for like an RF standard, or like an RFC for like communications, so that you don't have to request a new spectrum for communications for every?
It sounds like a exploitable, sounds exploitable, yeah.
I think just in here, you did, the FCC, but it's an international standard that's done by the UN, UFC.
Yeah, the ITU is usually you file your request for spectral access through
That's right here
ITU.
in New York.
So, but it's not it's a non-trivial process, and you know, for some small sets, you can use the amateur bands because it's not a commercial. Mm-hmm. Right. So one of the student projects use the amateur bands, but you know, it can be not only just for your broadcast, but also what they call the landing rights. So, you know, can we actually get this down to the ground? And those landing rights are usually controlled by the country of interest. So, and even though you may have permission to broadcast, you don't have permission to broadcast in that area. So, and there are a number of groups that are keen on that. And if you have any questions, I can direct you to, you know, just in Silicon Valley, we just started a Silicon Valley chapter of the Society of Satellite Professionals International. And one of the things that they address is an understanding of communication requirements and licensing and those sorts of things. But it's a non-trivial problem because you certainly don't want to have RF interference given other things that happen to be happening in that area. So, other comments just on companies. Bob Richards raised close to $40 million for Moon Express. So that's not just low Earth orbit, but if you look at Moon Express, Astrobotic, the guys that are planning on landing on the moon, even Space IL, a number of international teams. To me, this is something that not everyone is really talking about. And it's,
How much, you know, when you throw these numbers around, I can't feel this thing that they're small, not large. You know, if you tell me, okay, you got 150 billion spent on project XYZ, I think that's up, okay, that's like a peck on the $35 million, I think, going to the moon.
it depends on what, you know, you can probably do the moon for less than 100 million, given,
Really?
yeah, given what the GLXP is looking for. It depends on what you're,
15 billion? Or just
no, this is just the lander.
Just the land.
That's just the lander, yeah, not people, just
So
having a commercial company that's like,
there's 19 investments for 37 million. Are these just interested rich guys? Because I don't
see
Certainly not.
what's your return on investment for putting a lander on the moon?
Well, I think Bob Richards and a lot of those guys are looking at what are the rare earth metals that you find on the surface of the moon.
Mining project?
Yeah, mining project, and perhaps the process of extracting water from the moon and how that would build up into a
Well, they said there's a lot of water on the South Pole.
Well, yeah, and I think that's one of those. Yeah, that's in the shadowed craters
Yeah.
where you have gathering of any gas molecules.
So they know what it is.
Yeah, but you know where it is. But the L-Cross mission slammed a probe in there to measure some of the water content, but we really haven't landed anything in those craters to actually lay claim to that material. So, but
I mean, I love this stuff, but I just don't see the ROI. You know, we're talking like decades. Scores of
I
years.
had a conversation with Bob Richards, who claims that he's going to make money on the first mission.
So pictures?
Well, it's a
Okay.
combination of things,
Something
advertising,
yeah.
data.
Well, I guess you guys,
Yeah.
you guys had Alan Stern here.
Does he believe that just because he lands a lander on the moon that he's got claim to the mining?
No, not that. No, he would make money on selling the data that he collects.
No, not yet.
And it would be advertising and related kind of marketing ways of generating money.
But the American president will put down.
Yeah. I would
It's
suggest.
gonna say Summer Olympics 2020.
Yeah, but Bob's got Naveen James as the key investor for his program, and yes, it's a well-to-do Microsoft.
Because this is just an idea, he's been working on this. I've known him.
Yeah.
So say if you take it, he's already taken this one.
Yeah.
He's done it.
So, and to the extent that you've got a government customer too that wants to go back to the moon, certainly NASA is building their rover. They're planning to deploy that with the Japanese.
Well, once he establishes the methodology, then he has the standard operating procedure that goes up there. That's a huge, I think it's probably more important than actually going over.
That's part of, you're putting that whole system together and be able to turn the crank later on. But certainly getting Bob here to talk to you guys about his program if he's.
Well, he's
So-
stipend.
Yeah.
He knows the person.
So, and then on this, just within the last year, you have money that's flowing into SpaceX and Virgin and Qualcomm. So, but the comment about what it is that East meets West on this, I thought was, Peter Platzer, who's the CEO of Spire, saying there really is no investment in space per se. And what there is space investment in big markets. The question is the moon really a big market? Who's really going to benefit from that? Yeah, so, but, yeah, so, but that, investors are attracted to large markets with disruptive technologies. And that's what I see as what's really taking place here, is that rather than the technologies being specific to space, they're technologies that have large economies of scale within our own ecosystem that are being applied to space. And you've got companies like SpaceX, which are doing the reusable first stage associated with the Falcon 9 vehicle. And if you look at the top aerospace companies, I mean, these guys are paying out billions of years in dividends. And why is it that major aerospace companies are not doing what Musk is doing on this? As that's 70% of the launch cost is associated with the first stage.
Well, I did hear Golden from NASA saying he wants to not be, he wants companies to, he wants more of a private public model for these sorts of things. So NASA wanted to get out of the rocket business and have other people do it to stimulate business on a whole instead of taking on all the costs.
Yeah, if you look at how SpaceX, the relationship, the contract relationship that SpaceX has with NASA, it's completely different. And there was even, I was sitting in a meeting where they were having a telecom, and SpaceX said, actually, we're going to combine 2 milestones into one mission. And SpaceX gets paid based on the milestones. And the comment on the phone from one of the NASA participants is, "Oh, this is great. We're actually saving the taxpayer money." And you're like, "No, you're not. SpaceX is saving money because you pay SpaceX based on the milestones. If they do 2 sets of milestones in one vehicle, they're still getting paid the same amount of money, but they're just doing less work." And this was after, and so I think even within the NASA crowd, they're kind of unclear as to what's happening on that. But certainly, it's a redefinition about how NASA does programs. So you don't have a lot of post-engineering. You don't have a lot of people looking over your shoulder saying, "Why are we doing it this way, that way?" You're like, "We just want to pay for the ride." And it's been a big step for NASA to do something like the commercial crew vehicle, where they're not in there reverse engineering everything and saying, "What about this? What about that?" And that they're trusting the industry to do it properly.
And I think what people don't realize from the NASA way and the commercial way, it goes down to the cost structure. It goes down to the contract itself. Because I mean, I love that analogy because I fought with government contracting officers who were damned and determined that they were going to force a cost plus contract on us. And the private space companies are going, "Wait a minute, we're working on milestones. We're working on deliverables, which means the risk is ours. That is, if we don't deliver, we don't get paid." So, this day and age to hear that, oh my God, wait a minute, at least NASA still doesn't get it, government still doesn't get what a firm fixed price contract is. And I think it takes time. It takes time, but that is the level that we're going down. Not just these companies are building the hardware and building the technology and flying these vehicles or launching these satellites, but just the whole mechanism, the business operation of how these things get done. I think that in the end is the real story.
Yeah. And to me, this is a big, why is it Musk is the first one to be doing a reusable first stage on this after decades and decades of launches to low Earth orbit? And that's, with major companies that are paying out, from a financial side, I'm going to pay a dividend because I kind of don't know what to do with the money. Right? There's nothing I could do with this money internally that would increase the ROI for my company. So maybe you can explain to me how you make that decision. But in that context, I would say that there are disruptive technologies that are all around us, and certainly in the small satellite area, we see the benefit of mobile devices, and cloud computing, and not quite yet the Internet of Things. But I would say that many of these areas are what are funneling into the new space arena, and that you're able to take technologies that have large economies of scale and flow them into different verticals. And this is a figure that's from NewSpace Global, how NewSpace Global looks at the different verticals in the space sector. And it goes from one end, spacecraft, to launch vehicles, to human space flight, so forth, all the way down to space solar power. I think you might say that market maturity is highest for those things that are on the left, and sort of lowest for those things that are on the right. Space resources is, Bob Richards and over here, I don't know if you see that, here's the Moon Express route, but with that,
Is Caterpillar thinking space resources?
I think they're part of the Caterpillar is part of Astrobotic. So that's part of what Redwood is partnership. So And then along these verticals, you have a wide variety of companies. I believe Maiden Space is here. Here's Spaceland, Mojave, and so forth. But I would look and say, well, you could probably take these technologies up above and kind of map them into all of those verticals. And this is just kind of my take on this. But that for spacecraft, pretty much all those things flow into the next generation of spacecraft that you see. And very keen on what's associated with additive manufacturing and how that whole technology is going to disrupt just the manufacturing industry and change how you think about alloys and the design of materials and the actual printing manufacture of them and how they can be incorporated.
What's microgravity research? Is that biological and chemical?
That's a combination of those things, biological and chemical. Nanoracks, nanoracks has demonstrated protein crystal growth on the ISS, where protein crystals are extremely difficult to grow in a 1G environment, but you can grow fairly large crystals, which you can then use in a X-ray diffraction type instrument in order to measure protein crystal structure. And there's some other groups that are working on fiber optics. Fiber optics working in the near infrared, and they find that they manufacture them in a microgravity environment. They have a lot more throughput than what they do in a 1G environment. So, and to me, the microgravity research, I look at that much like how we look at nanotechnology. Right, a decade ago, there was a big thrust on nanotechnology research, because what was happening, people making nanoscale devices were seeing effects that they did not understand. And so you've got to go in the lab and reproduce this and try and figure out what is nature really doing. When you made those nanotech labs, and we were talking about New York having major centers up at Albany and elsewhere, that they didn't build one nanotech lab in the middle of the country and then have researchers send their ideas to that lab and have those lab experiments executed by researchers that were there at the lab, and you kind of had to radio in and figure out what was going on. What they did is they built laboratories all around the country. So there are laboratories in New York, Brookhaven, all the DOE labs have kind of a nanotech component. Lawrence Berkeley, Los Alamos, Sandia. And then researchers go in and they observe, what is nature doing? So I believe the microgravity story is somewhat of the same, that in order to really understand how nature performs in a microgravity environment, it's not by sending experiments up to the ISS and having a boutique pool of astronauts execute them. It's really from researchers that have direct experiments with microgravity, figuring out what nature does, much like how we run the nanotech labs around the country. And so I think the opportunity for NewSpace is to provide that ready access, and that's ready access through parabolic flights, through X-Core, through Virgin Galactic, and perhaps even with commercial astronauts going to the ISS. I might suggest that one of the first commercial astronauts for the ISS might be a NanoRacks astronaut, where that astronaut has responsibility for executing the NanoRacks payloads that are up there for microgravity.
Is that something they're talking about?
That would just be, I'm just, hypothesizing.
There's a company that you could hire, would have astronauts for hire, and even Southwest Research Institute are putting their own astronauts for that purpose eventually. Yeah.
But not, you don't necessarily need astronauts. You send,
Yeah.
SpaceX
Well,
sent some experiments to ISS and found 40% differential in the rate of enzymatic breakdown of proteins in microgravity versus on Earth. You didn't really need astronauts to do that, right?
Yep.
A lot of this stuff can be automated. And
Right.
so with satellites that just happen in ISS, it's very interesting to see
Yep.
what other types of laboratories might be available.
And and we talk about things that are here in New York. I mean, one of the robotic lab groups that's over at NewSpace, I forget which company that is, but people are looking at how can you take robotic technology and apply it to labs on the ground? Transcriptic is a company out in the Bay Area, but there are companies out here that are thinking along those same lines. And to me, an interesting area is the combination of biology and what you're doing on the ground applied to a microgravity environment, and taking some of the robotic technology, augmenting that with what you have in the International Space Station, and coming up with experiments that are relevant to this research. So here, I say, I don't even know what happened to my cursor, but yeah. So for the microgravity research, I would say, yeah, it's probably mobile computing, the guys that are using Arduinos and some of what you find in your cell phone, because the radiation environment in low Earth orbit is not so bad, which is why we live there. Materials and bio, how all that can play into microgravity research and the robotics.
And usually some presets, for example, how you provide power. So that's very interesting.
Well, the thing I like about the ISS is you've got buku amounts of power and buku amounts of communications.
Yeah, but there's energy experiments done in microgravity, a lot of propulsion experiments, fluid flow, on the physics side. Yeah.
So,
Capillary.
that's just like the AI topic, because when you go out to singularity, Ray Kurzweil's like, how is AI going to take over the world? And so I would say, how does AI figure into these things?
So essentially, in New York right now, there's a woman that came to see me at World Science Festival yesterday, came to see me again today, and she's involved. She came here for the singularity that we found out.
Wow. Okay. Yeah. So, and these are disruptive technologies that have large economies of scale. Pardon me?
Singularity.
Yeah.
When you said singularity, then I was like, did Google become alive? Like,
That's the
well, you go out and you follow what Ray Kurzweil has to say, and the question is, okay, when's that going to happen? But it's pretty clear to people. Well,
when I talk to the people at MIT, it's not a question of when it's happened. The question is where has it happened already? Yeah.
So, but clearly it's going to have big impact.
People are younger than the Olympics in Eastern time, not in space.
And these are some other slides I had, because this was part of a in situ resource utilization, which I thought was was interesting in terms of what you know about asteroids. Because on this, what happens is that, if you look at asteroids, you have a pretty good idea of what are the large objects. What are the objects that are 1 kilometer or larger? Those are things that we detected from the ground. The census for that is you got probably about 95% of those objects in a catalog where you know what they are. But as you go to smaller objects, you really don't know much about them. Yes, they're probably the result of collisions of the larger objects, but that there are a variety of other missions that are coming online, like B612 and the NASA WISE mission, that are intended to map out these much smaller objects. And it's the much smaller objects that planetary resources and deep space industries and everyone is focused on asteroid mining are going to look at. So it's the objects that are down here at 100 to 300 meters, if not smaller than that. And there's really not a lot known about those objects. If you look at particle collisions, if you have a bag of rocks and you smash it on the table, you get a power law distribution. And so what you're saying is, I know what the big rocks are, but what are all the small rocks, and then where are they? And then how can I track them? How well do I know those orbits?
Can you come back there for
Sure.
a second? I can't read the,
Oh,
I can't read the stuff, but so there's more bigger rocks? than
actually,
there are
what it's a
smaller rocks? How does that work?
the result of this was that for the WISE mission, they actually said the old predicted value. WISE was an infrared survey telescope that was launched by UCLA that surveyed the sky. And based on their results, they thought, here's what we thought the population, this is what we thought the population was pre-WISE. And then the results of this paper was, actually, we think there are actually lesser objects. So if you look at a power law, this is saying the slope of the power law is not this, it's like that. So it has a better handle. WISE measurements were making a better, had a revised prediction as to what the slope of that power law distribution was, so that you actually, you lose a small percentage of the larger objects, even smaller objects, it's a larger percentage, a good fraction. So I think the thing to look at is not the old predicted WISE, but just the new predicted WISE. The point I was making is that you really only know a few of the objects. This is the rest of the population, which is unknown. And then the measurement was one of how big is that population? Like, actually, it's a lot smaller. It's just
Actually, like, senior project, I work with senior objects, and like each year, each month, we into the file line, and then we go with the program, and then we try to identify the new objects, like we monitor the test and the computer, and like maybe it's only the one part because we try to do that after. And like we constantly actually found 2 new objects on each one.
Oh, really? Okay.
Yeah,
How large were the objects that you guys found?
Around like I identified 170.
Really? Okay. Yeah. Because I always figured the things that are the smaller that you pretty much need sort of an cooled infrared system to go do that.
Yeah, and that was checked by other professors.
Mm-hmm.
Maybe something. Like
Yeah. What was the source of the data for that?
It was actually. I think I don't remember.
Was it Spitzer stuff, or was it WISE stuff, or was it?
It was by NKC.
By which?
NKC Station Information Council. And it was by Young Eye.
Okay. Okay. All right. Yeah. So I mean, I think the point is that for the smaller objects, for smaller objects, you know less about those than you do for the bigger objects. And but
Why is it so important to find out what's going on?
those are the ones. Yeah. Well, those, I mean, just from an astronomy standpoint, you want to know, what is that power law distribution telling you about the history of objects in Earth crossing asteroids? Why is it? How can you understand the physics associated with the formation of these objects?
You don't have to be one for that.
No, you have a statistical. Yeah, this is a statistical argument. But what you might say is, if we were going to go out and mine asteroids, which are the objects that you would want to pick, and how are you going to select?
You get the 100-meter ones and put them in the truck. That's great.
Yeah, as opposed to the larger one. And for these guys, to me, you like why is it you wouldn't go after the larger objects?
Mining equipment.
So, yeah, if you wanted to capture them and bring them back. Because some of the things that they're talking about is being able to capture them, bring them back, put them in a lunar orbit, and then be able to mine them there. You're probably not going to be able to perturb the orbit for the larger objects, but the smaller ones, you could perhaps capture and then bring home and then decide what you want to do with them later on.
What's the time frame that we're speaking about mine exploration?
Well, this is, here's a sample mission for what was done to the journey to Eros, and it shows the launch in '96, and then a bunch of different trajectories. So that here you are in February of '96, launching, going out on one orbit because you want to synchronize this orbit with the orbit for Eros, which is slightly larger than the Earth's orbit. But here you are with one maneuver out in '97. 6 months later, you're coming back over here in '98, basically 2 years later, and then doing a flyby in February of '98, and then another maneuver in '99, and eventually arriving at Eros in '00. So, I mean, you're basically spending 4 years between when the launch occurred and when you actually rendezvous with the object. So, is it 2 years? Is it 3 years? It depends on the object, but it could actually be a significant amount of time. And then for this, we kind of broke it down into similar kind of verticals of the things that you have to do in order to do asteroid mining. And the first is doing a survey and figuring out which of the objects you want to do. And then much like there's a program within NASA about how they view planetary exploration, and there's 5 points are flyby, orbit, land, rove, and sample return. So this is essentially that, with also figuring out which of the objects you want to do, and you have to go through all these steps. And that when you do an asteroid flyby, you're really looking at mapping out the gravitational field of an asteroid. You want to look at, when you go into orbit around it, you want to look for any orbital debris associated with that asteroid, because it's not just the object itself, anything that's around it. Landing it, you have to get the exterior structure and interior structure if you're digging into it, and then composition. But I think the point I wanted to make is that even in this, for all these different steps that are associated with asteroid exploration, it's the same. It would be the same story, that you've got disruptive technologies that can potentially flow into these areas that are probably essential for figuring out. And for some of these other things, as we talked about the singularity column, rove and extract, is that important? How is that going to factor in? But then, yes, sir.
How much could something like a light sailor and ion engine speed this up? If they couldn't just rely on gravity assist.
That I don't know. I don't know what the answer to that is.
Anybody working on power, this is a big bugaboo of space.
Yeah.
Everything is gravity assist, it takes years and years.
Yeah. Well, that's one of the companies that we have is Positron Dynamics, which is looking at the ability to use antimatter as a propulsion system. And those guys there's some PhD researchers that have been able to pull out a bit of angel funding to go do their work, and they're actually
Thermonuclear, which is usable, but nobody seems to use it, and I don't know why, because most start throwing things that are radioactive into orbit, everybody gets noticed. But it's pretty radioactive.
So
right,
But no one's been blown up by an antimatter anytime.
Yeah, I know.
Yeah.
So, I mean, that's an issue, and I would say that how are people investing in that, and for any of the antimatter engine proposals that we've submitted, they kind of don't get any traction out of the NASA crowd. It's been interesting that they've been able to get money out of angel investors from Silicon Valley before they've been able to free up any money from NASA on this whole thing. And that's just the way it is. I'm like, isn't that an odd data point?
Well, yeah, that's today, and then
Yeah.
10 years from now, that'll switch again.
I don't know. I would say 20 years ago, it was already switched, where you could get money to do that stuff. But today, that's even out of the NASA's Institute for Advanced Concepts. They're kicking stuff like that out.
Very dead,
But I just, in kind of wrapping this up, I didn't mean to go for so long. There was a very interesting comment made by Steve Squires at the Augustine Commission, where he talked about the value of manned exploration. And his comment was, Steve Squires is the PI for the 2 Mars rover missions before, I guess it's Curiosity that they have now. The other 2 rovers, the first 2 rovers that they sent, Steve Squires' comment was, given the multiple years that those 2 rovers have been operating, Harrison Schmitt, which was the last astronaut to the moon on Apollo 17, he was also the first geologist to go to the moon. Steve Squires' comment, as a geologist, said, Harrison Schmitt accomplished more during his few days on the moon than we've accomplished in multiple years of our 2 rovers on the moon. And it was a comment that I did not expect to hear Steve Squires say. But I think it's a telling comment about what's the importance of having a man, woman, mankind in the loop as part of the exploration process. And if I was to say anything, the real inflection point for space flight in the 21st century, I think, is manned space flight, and that you'll have more people participating in space in the decades to come than what we've had in the past. And one of those things is a company we work with called Integrated Spaceflight Services. There are lots of companies that are part of that microgravity experience, but I think for parabolic flights, this is really an opportunity to understand what life is like in a microgravity environment. And out of the flights that have been supported by NASA over the last couple of years, there are a wide variety of experiments that are hardware experiments and biochemical experiments, even human physiology experiments that are done and allow people to actually participate, much like that statement about, you need people, you need researchers in the nanotech lab, you need researchers in the microgravity lab. If you look at Made in Space, which deployed the 3D printer on the International Space Station, they did 400 plus parabolas on the zero-G vehicle in order to prove out their technology and to understand what life is like working in a microgravity environment for their engineers. And to me, that's a very telling. It's not just, I've done 15 parabolas, I'm a joyrider, and I'm going to do 15 parabolas that I've done. It's that I'm a company, and I need to understand how my instruments and how my technology is going to function in a microgravity environment. To me, the real market is not the space tourism market, but it's companies that are saying, I need to do this because of where I fit in the value chain. People may say, well, Made in Space, what's the real business model? But I think Made in Space is an opportunity. If you're thinking about technologies that want to work on the ISS, you should look at how I could use Made in Space. Made in Space is probably the fastest way to get an idea up to the ISS. And they printed they had a socket that they printed. And then the astronaut said, wouldn't it be nice to have a wrench to go with this socket? And so in essentially 1 week's time, they designed the wrench, they got it approved, they sent it up to the ISS, and they got it printed off. I think that's probably the fastest delivery of anything from someone in low Earth orbit that said, I want a, and then.
That's way too slow.
Yeah.
For a
And,
wrench.
well, it's.
You're on the International Space Station, that's not
It's pretty fast, and I think that's, if you're thinking about, I need to build something for the ISS, you should look to Made in Space and say, how could I build it using the technology that's up there?
3D printer, is that metal or is it plastic?
It's plastic, but a metal printer probably on its way. Made in Space is doing their second generation printer.
Still plastic.
I think so. Yep.
Are there
It's-
metal printers?
Oh yeah. I mean, if you look at the new rocket companies that are coming online, what are they doing? They're 3D printing their engines. I don't know if that's.
Are they additive or are they?
Yeah, it's additive manufacturing. They're taking titanium powders and making components.
And I went to SpaceX initiative, you see metal that they have printed there, you can hold it up to the light and see through it because they made it that way. It's just not dense. Yeah.
And-
It's fascinating.
So,
What's that?
that could be disruptive.
Some parts, yeah, and some parts are metal.
But-
We
And
have like these shotgun manufacturers.
Mhm.
You're just trying to figure out what they
number
Because
of,
like, the 3D printers are plastic.
They're
Plastic.
Yeah.
Right, because it's just more. Who's building a car engine, you need something surrounding.
So-
As I was saying, it's plastic.
and you take metal powders. There's two kinds of printers. Take metal powders, you expose them to a laser. It melts the powder and makes that little nugget of pixel of a component. You can also use an E-beam and collide electrons into it and sort of do the same. So there's laser technology and E-beam technology. You have the powder, and the powder can consist of titanium, it can consist of multiple metals kind of mixed together. You can do multiple alloys.
You don't just have like a piece of scrap.
For subtractive, you take the big block of metal, hog away everything that doesn't look like your final part,
Also, it's extremely high risk in space to have those pieces of metal flying around.
There's certainly
There's also the problem of having those spare pieces of metal in the station.
so there are challenges, but that's why you're like, is there a 3D printer on? Is a metal 3D printer on the ISS today? No. Do you think there will be?
Yeah.
Well, Bagaville,
ISS.
Bagaville propulsion, they're doing
Yeah.
rocket engine better.
Right.
3D printed rocket propulsion.
Right.
Basically.
So, and then my last plug on this is Space VR, which Ryan Holmes came up with this idea for doing a 360 stereoscopic imaging camera on the ISS. And so he's in the process of doing a Kickstarter program for his effort. And if you've been looking at Oculus Rift, Oculus Rift is a viewing mechanism. And the question is, what's the content? And Space VR is saying, well, of course the content needs to be space related. So you design a computational camera that takes in a full 360. It's actually a 4Pi view, but people like to call it 360, and it's stereo. And being able to do that on the ISS, whether it's for viewing out of the portal, whether it's for engineering activities on the ISS, so you can see what's my 3D printer doing, for being a remote observer for whatever the astronauts are doing. And I think for Space VR, that's an example of a young entrepreneur who has an idea, and all the pieces are in place for building it. He's actually building part of it with made space for the camera holder, get it delivered up to
Google just announced a protocol for camera this format.
Who did?
Google
Last
week announced a protocol for 360 cameras, and they're partnering with like GoPro, and so there's been a bunch of consumer 360 cameras.
Yeah.
Google I/O?
Yeah.
Okay.
Where is it? Is he in the Bay Area?
Yeah. He's got his offices over in the tech shop. So, and I just throw this out there is that we had our tech talks, and it was after the tech talk, Ryan asked me, he said, I've got an idea. What about taking a 360 camera? And I've, been following what's happening in computational cameras, like, can you really do that? And, today he's been working on this. He's actually pulling in a kind of a friends and family round. He's expected to do his Kickstarter later on in the summer. And we've been talking to NanoRacks about getting the cameras up there. He's going to do made in space. He's going to print a holder on the 3D printer, integrate it all together, and be able to take some images, ship them back down, either ship them back down digitally or just take the memory cards and put them on the next flight on the way back. But to me, it's a great example of how you can take, novel ideas and really implement them given the supply chain that's developing with Made in Space, with NanoRacks, with cases, and a lot of the people that are pushing for commercialization of the ISS. So my last slide on this is perhaps one that it's not all just about images and things, that there are lots of major problems on the planet that we all need to pay attention to, and they are the environmental and climate impact. I don't know what we're going to do for political violence and global poverty, but if you could come up with an app that would solve these things and how space is able to do that, we'd all be a lot better off for it. And then the last comment is just about NewSpace, which is going to be in July in the Bay Area. And that if you haven't followed, there's tons of conferences that are coming online. We've got a conference that's showing up in November in Houston. NewSpace is in the Bay Area. Welcome everyone to kind of come out, and I will treat you all to a drink. Maybe I shouldn't say that. Yeah. What I'll do is I'll figure out who's going to be buying them all. Come out, and, I got some people queued up that lots of tasting.
Bay Area.
Yeah.
Get Dougal to come and bring his wine.
Ah, okay, right, yeah, right.
I'll give him a call.
Yeah, no, that's the kind of way it is. It's like you get an idea, and you're like, oh, how can we solve that? Hey, I know somebody.
Dougal, he's right up the street. He's got his own vineyard.
Yeah.
Actually, next summer, go out there. They're going to
Yeah. So anyway, but
I like your visual with the World's Fair.
I'm a New Yorker, right? I mean, I remember going to the '64 World's Fair. right? And because that, you know, it was about the it was about the global community. That was intended to be captured by the Unisphere.
So it's 1939. See how well that went?
So yeah,
That,
you see how well it's worked over the last 50 years.
Actually, 39, I mean, that was a progenitor of Disney. Up to 39 altogether, we wouldn't have Cinderella.
So that's kind of my perspective on Silicon Valley with a little bit on Westwood. So with that, I open it up for questions and comments. Any other discussion you guys want to have?
We should give them a round of applause. I have a question about startups. Do you think that there are lessons that startups in the Bay Area how they have benefited from these developments in the space? And to what extent do you think that we here can learn from their experiences and also maybe leapfrog some of the challenges that they face so far?
It's that it's accessible. What's happening in NewSpace is lowering the barrier to entry to doing things in space. And so with regard to companies, to me, what's always important is, it's almost like I assume the technology is going to work. Tell me about the market. Tell me about how big that market is going to be and kind of what problem it's solving. And then from that, it's the standard stuff. Who's your team? Is this a team that's really going to be able to raise all the money that's needed for that? Along with what are the issues about competition and your competitors, and certainly what's your barrier to entry on that. But I feel that in NewSpace, we've got companies that are coming online that make it easier to access this environment, and that the cost of doing that is kind of comparable to what you could have as an early seed round, a couple of million, then about 10 million, then about a couple of million, 20 million, 70 million or so. And you can kind of follow the standard formula for investments in companies, and that in NewSpace you can actually do quite a bit with that, even to the point of, it's getting something to the moon is probably about 2 million per kilogram. So if you have a cube lab type module, whatever it was you wanted to do, if you wanted to extract helium-3 and convert it into fuel or something, can you think about putting it in a 1U or 2U garden? And that for a couple of $1 million, you could get that to the moon. And that couple $1 million that's what you could write in a grant. That's a number that typically kick around. And with Bob Richards going to the moon, or Astrobotic or any of those things, you'd say, okay, I want to get this to the moon and do that. And so I think it's remarkable that for just a few $1 million, you can actually have access to the lunar surface and kind of everything in between. And that's, maybe it's the economies of scale that allow you to do that. And yeah, you're going to have a harsh radiative environment, and then you got to figure that problem out. But, it's something that you could prove out that technology with parabolic flights. You could do a choice between, do I want to do a parabolic flight, or do I want to do export, do I want to do Virgin? All those price points are kind of around the same thing. How many flights do I get? That kind of stuff. How do I prove out my technology? Do I want to run it on the International Space Station where I get days and days of microgravity experience, and then do I want to deploy it to the moon? All those things are kind of coming into play, and I think they're coming into play at price points that look attractive from an investment side. Whether the return on investment is attractive and how you're going to tell that story is kind of up to the entrepreneur. I think that would be my comment about why NewSpace is entrepreneurial space. So
A lot of these businesses are what one would call, probably from this, a moonshot. So how
what adds credibility to a startup for investors for space?
Yeah. That you have, some experience in that area. And I think you can, gain experience on that through other programs that you're doing. Some of it is just, it is kind of a stretch, but certainly it's a team. If you've got, a bunch of software guys that are trying to do a bunch of hardware projects, that's going to be a problem. But I don't know if I have a satisfactory answer, but you've got to be in the industry doing something along those lines. And I feel that there are enough enough sort of aerospace engineering talent that you could employ to make that happen. If you've got kind of the overall business case that you can say, look, here's the team that we have, and we've got some core people that are coming out of university programs where they've flown payloads on parabolic flights or something to have experience with the hardware. And I feel that there's enough kind of people that are out there, and of course you've got to come up to speed with what you're trying to do. So
I also think it's prototype. You have to
Yeah.
have shown, I mean, if you're going to build hardware, you have to have shown that you can build it. I mean, like to your point, the software engineer building hardware, you think just go in and say, hey, we want to do this. I mean, anybody can make anything these days, anywhere. And so, if the software engineers haven't been doing this in their spare time and on their weekends, then it's not going to fly anywhere. It's, and your investors are not just.
even if you were talking about Bagabine.
Yeah.
Bagabine was an engineer that was working down at X-Corp. And he came up when we had the X-Corp workshop. Bagabine came up for the workshop, and he's like, it was one of those things where like, oh yeah, sure, you want to come? Yeah, happy.
Yeah.
And
It was new at Expert too.
yeah,
He was
and
pitching his idea.
yeah,
Even then.
and
What was the idea?
This 3D propulsion system, 3D printed rocket engine.
and so he's been able to pull together his team. I mean, he's got core expertise in that area. That's what you want to look for. Is he going to be able to grow the company and migrate his talent from just an engineering side to, being able to run the company and all the human, HR issues associated with that, will be a challenge for Nadir in doing his company. But it's like anybody that's, I'm kind of the founder of the company, but am I the best person to run the company? Can I morph my expertise from technology to going out and acquiring the funding and to running the company? All those things, those are all different skill sets. I think they typically say, you need somebody that's going to go out and pitch the idea, somebody that's kind of a visionary for where the technology is going, and somebody that's going to handle finances, and then somebody that's going to really be a master of the technology. And those four areas you need to make sure that you're able to cover it.
So you might have gone through this already, but in NewSpace, the question's kind of twofold. Can you talk more about, some of the startups that are working in or seeking
Yeah.
some of the services? Because it sounds like,
Well,
you talked about they need to almost approach you like that.
no, I just like with Ryan on that. I don't know. That's for me. I look at stuff and say, oh, does that make sense to me from the technology side and kind of from the business side? With Ryan for his space VR, I like the fact that it's relatively straightforward technology, but going to have a huge impact. It's kind of like Netflix for space. And, how you do the revenue model is TBD. How are you going to generate all that content? I don't mean TBD, but there are lots of different ways to do it. You have a price per view? Do you have a subscription model?
And you're looking for, I guess, your clients to come to you with this business model, or is that something that you figure out?
No, well, yeah, I think sometimes it's, where people have that already figured out. Not everybody, there are some, there are plenty of people that, they're just going to go forward and do what they're going to do on their program. Okay, well, what can I do? But certainly, Silicon Valley Space Center certainly likes to participate in those companies, but then to the extent that we can add we have some value add onto the process is good. So, but I think it's kind of a mixed bag, because if you look at one of the companies that I was really keen with was Manu Sharma and Infinity Aerospace. And Manu was aggressively pursuing the Arduino to use as a Cube Lab and Arduino hardware. And I think he was looking more at sort of the educational market. And my own take on that was that there are probably things on the ISS that we need that could fit within that Cube Lab module. So it's not that you're selling an empty box for people, but you want to take that empty box and populate it with, biological hardware. You want to think about what are the pre-packaged, and then you're kind of saying, well, here's the form factor I have, and can I implement that? And Manu's story was A, he was running the company. B, he was going to Stanford and getting his degree, which was a tough act in and of itself. And then C, he was also trying to have a personal life too. And I think that yeah.
Did he accomplish all of it?
Well, I think, he graduated. He graduated, and right. He's graduated, and he's got his significant other as a relationship, as a going concern, last I heard. And is it? Yeah. Okay, so it's really serious. And then I think the Infinity Aerospace kind of like took a back seat to getting a job at a UAV company in San Francisco. So, when you go do a startup, you got to think, okay, how much runway do I have? Because you don't want to run out of runway, which is, I'm burning through my own money to make this happen. Do I have permission at home to go do this? Because a lot of people are like, you're doing what, when, for how long? And
I think more importantly, the other question I have is that when you think startups, like especially in Silicon Valley, like my idea is like a lot of these programmers or coders who covered in, because it's in a sense, I guess you're traveling light. I guess it's light knowledge in a sense. You don't have to be like a civil engineer who's carrying lots of people or anything like that. So civil engineer. Well, yeah, there's geotechnical engineering. So basically, there's these different types of engineering. I think, so to speak, like those who come from software, it's a bit more self-contained, or like a math background, or physics background. You can just go out and build a explicate from that. I just want to talk about, for some of the young people coming in, like what are different backgrounds as like entry level, because like there's a German engineer core, and there's not necessarily someone who have an extensive coding background, or well, typical profile of someone who just really competes all.
Yeah, well, I think that there's, you just can't have just a bunch of technical people running your company. I mean, I think the intent of that was that you've got, 4 skill sets that you need to have as the core of your company. You've got to have someone that's going to go out and raise the money. That's actually going to feel comfortable going out and talking to people.
Speaking about this in the context of NewSpace, right? Because that's, and then be worried about someone going out to raise their money if this is a true include program to that.
Well, that's, you're investing in the entrepreneurs. You've got to have, somebody that investors are going to trust with, that inspires trust as you're going out and raising the money.
So
and that
NewSpace for self
I don't think it's like Peter Plotzer's comment. People aren't investing in space. People are investing in big markets. with disruptive technologies, and they're investing in companies that look a lot like the other companies that they have. And
So you're saying
the formula is the same. I don't think the formula is any different. It's just instead of operating in the software realm, you're operating in the space realm. So if you're building the satellites, you better understand what are the requirements for getting that stuff to operate in low Earth orbit. I mean, you're going to need that technical component of your team, much like you're designing a search engine or any other piece of software. You need to know you need to have a discipline expertise associated with that. But your company is also going to have.
so one is business technology. You said it was four.
Yeah, and I would say you have sort of the person that's actually going to inspire confidence that we can raise the money on this. You've got somebody that's got the vision about where this industry is going to go, and you've got somebody who actually is grounded in the hardware that you're going to implement, and you've got to have someone that understands the financial parts. So where's the money going? And we're not going to have a lot of dollars locked up in assets that aren't being used. And when that whole group kind of gets along well, and you can kind of go into the process saying, well, we've got this, but we need some others. And hopefully, if you're when you talk about smart investors are ones that can help you with networking, ones that can help you find the resources you need for your company to grow and to fill in the gaps. And you can kind of go in and say, well, here's what we have. I generally like to say that what you have better be a good understanding of the market. Because if you just come in and say, hey, I've got this technology, doesn't anybody want to buy that? Somehow that's, not going to necessarily work. And even so, you're like, well, think about what problem you're really trying to solve and why that's an important problem. So even from the technology side, I think everybody needs to understand where are we going with this market and how is it, because the business side is always about the market and about your customers. Yes, sir.
Can I ask you a question related to the markets, right? So people are just repeatedly hammering on the point that you need to figure out the market, the business requirement analysis, and then you proceed from there and customize and build the hardware. So in terms of markets, do you really buy this hype that, say, let's talk about satellite imaging, for example, and small sats in particular, they're going to be truly disruptive across multiple verticals. And they might be disruptive. And if so, in your own personal opinion, how would you begin to rank these different segments or different verticals? So let's say I could clearly see agriculture being affected. Like you have a company like Climate Core coming in and doing this cutting edge big data analytics and customizing for the farmers. And at price points which are making a lot of sense, you could solve a big problems for Ghana or Argentina. Or you could get into, metals and mining or maritime domain awareness. So just at a high level, if you were to give dollar value, so I saw you mention MBA or maritime at $12 billion, right? Would you say agriculture is 1 billion or is it 20, or just some sense of the size of the market and the level of interest these things would generate for these companies to justify their movement and their valuations?
Yeah, I would, to me, the agricultural market needs to be a very serious contender for the satellite imaging. Agriculture and the things that are related to agriculture, in particular, water resources, and how you're able to measure what water resources are available. In California, people are going through the mountains and kind of sticking a pole in the ground for, here's what the snowpack is, and to be able to apply, what is global technology to look at those, to actually come up with numbers such that the state, frankly, the state of California can do a better estimate of, here's what we think is, the snowpack and how it factors into, our estimate of water resources. Probably on the mining side, I don't know if the imaging technology is really addressing the mining market because it's probably not through imaging, but through other technologies. That there's a whole path of what you have to do in order to fully extract resources that are embedded in the ground, and that typically is not just imaging technology, but also magnetic field measurements. Maybe in terms of which of the plants that are growing, because some plants prefer certain minerals, and whether you can pick that up or the imaging side is of interest. I don't know, what success people are having out of monitoring commerce.
Because that's what requires,
well,
like key flashes are.
Well, I think,
ships and ocean.
yeah, I think what Peter is probably looking at is that you have ships that are on the ocean. There's sort of no competing technology for what takes care of the communication and any other measurements that you'd like to be able to make for that. Just what their location is, and maybe some other things. So. Yeah, but how big is that? I mean, that's people that are people that are in trouble.
I mean, basically in billion-dollar rankings, right?
Yeah.
I mean, like one of the four major markets. Would basically small sats and various applications make a dent into the global defense market, for example?
Mm-hmm.
I mean, or is that like already super saturated?
Well,
I'm just trying to get a
first
order, high level thing. That, I mean, what are these numbers? Or are we saying that these companies are actually market makers? I mean, who really knows the agricultural potential for, like I said, Ghana or Angola, right? And they come in and demonstrate this, and they're like, whoa, it's like a multi-million-dollar, multi-billion-dollar.
It's very interesting to hear this. I tell you why.
Okay.
Somebody from the future of the economy is this. This better grow, and there better become economic blueprints for space-based technology. Otherwise, there's no place for this planet to go. We're growing our population, we're losing our resources, and we got to get off planet. And we have to start using it, and we have to get off. And this is just the beginning of it. So you better come up, so you're going to have to come up with markets. But the other interesting aspect of it is this: is that this technology, it's one thing to sit here trying to keep you out of business. I have a business, and you have an incredible amount of broad background in a number of areas of expertise: agriculture, mining, defense, radiology, radio communications, computer software, and so on and so forth. It's amazing. But when you get through with any of these technologies and you launch them, let's just take the moon lander for an example. You're really depending on, in the end, of generating a new market that doesn't exist. So you're not going to be able to go over and take a market survey and see 45,000 people who are going to drink Coca-Cola in the next 25 minutes. And if I can make these cans Coca-Cola, less expensive, make these cans, I can make a profit. This is not what the space technology is for.
Right, and sorry, we have only 5 minutes because the room is booked until 8. So
But I would say that part of the challenge for these satellite companies is to identify the untapped markets. And for geospatial data, it's not just companies like Google Maps, but how is it that Yelp or some of these other applications that are relying on geospatial data can take advantage of what's being provided through the satellite systems, and even for boutique satellite applications. I was listening to the U.S. Commerce Department talk about what's going on in Indonesia. One of the banks in Indonesia has their own satellite constellation, which they use for transactions and doing the business. And so the fact that you're able to break into markets that provide new services that otherwise were unobtainable is probably, an interesting aspect of what's happening in NewSpace because of the lower price point. That much like Planet Labs can have their own global platform for imaging, other industries can have their own boutique platforms where they would look at it and say, gee, I could never own that before, but maybe now I can do that, and then what are all the things associated. So I think when you lower the barrier to entry, then you probably bring a lot of new entrants in there. And I don't think we've started to tap into what those possibilities are. Because if you look at Skybox founded in 2009. Where are we right now? 5 years later. So I don't think it's really hit its stride. I think we'll see a lot of other companies want to take advantage of those technologies that offer Bitcoin services or what have you.
Just as an example, so maritime shipping, there's actually a Japanese company that launched a satellite that goes up, looks at the Northwest Passage for this Japanese shipping company that can actually take advantage of climate change, where they're actually watching where the ice is melting, so they can find a quicker way.
Yeah, I heard about that.
Over.
A while ago, I read about that.
They launched probably a year and a half, maybe 2 years ago, this satellite, and it's specifically for that. So, they want to find the quickest route, watching the ice melt. They have their satellite up there, and they can direct the ships almost in real time to navigate.
It seems to take road trip before it that's incredibly efficient. I mean, when you have your own, satellite that's tracking sardines off the African and pushing these coastline, it sure is going to make you more efficient a lot easier. Probably a lot less destructive also.
We had a Wharton guy was asking me to put on NewSpace panel, so we had a couple of people there, but Planet Labs we see right next to Northrop Grumman, and Northrop Grumman's comment was, I don't know why you'd want to image the planet on a daily basis. Their response to Planet Labs business model. And you're like, did I really hear that? But
doesn't surprise you.
But and whether they meant it or not is something else. A bit of disinformation. But there you have it. So, and I think it's up to with the technology, it's up to kind of dream. It's up to entrepreneurs to dream up where are the opportunities for perhaps the non-standard.
But I don't know how to this. I'm not sure how much time we have, but many times the technology remains tradition. That's all physics. The physics has been demonstrated. The technology is there.
Yeah.
So now you're saying, okay, I need to be creative and see if there's a market for it. And there have been numerous instances when it hasn't borne out. So I'm just scratching my head and wondering that is it a bit of that element as well? I mean, if you look at all the big boys, right, with billions and billions of dollars, and there have been massive satellites with these tremendous resolutions, and vast sections of Earth's terrain has been covered. So it really makes you wonder, this new players.
I don't know. I mean, I call back, I was not, when they were talking about Zipcar, I'm like, how is that going to work? Right? I mean, who really wants the Zipcar service?
Because that was an obvious one.
But Zipcar doesn't build their own cars.
No.
Sorry, guys. We
Cars
really have to wrap up. Yeah.
What I was thinking was.
Guys, let's keep the discussion for the first.
Not knowing technology and the trademark, you knew that you needed that technology at work. And I'm thinking about some guys that were pitching something last year that would enable insurance companies to reduce their costs and shipping companies to reduce their costs because they understood the shipping industry that well. You know how the satellite application would apply to that. So I think if you know an industry or you know about it, then
Right. But the real growth.
Yeah, sorry guys, we had to wrap up now. And we're going to continue this discussion outside, but just want to thank you again, Sean, for being here, and thank you very much.